Living in a country almost swallowed by sand, where more than 95% of the land is desert and rainfall is nearly non-existent, Saudi Arabia has achieved something unimaginable, building a massive steel water delivery system from the Red Sea to sustain the entire nation. Every day, billions of liters of seawater are drawn into large desalination complexes, then pumped across the desert through a pipeline network stretching thousands of kilometers. Bringing water inland from the sea is already a remarkable engineering feat. But turning salty seawater into fresh water fit for drinking, farming, and industry is what truly earns Saudi Arabia global respect. So how is this invisible river of steel built and operated? Join Mandarin Tech as we uncover the answer. Saudi Arabia has more than 37 million people, and almost the entire population follows Islam. What is particularly notable is that most of the population is densely concentrated along the Red Sea coast and the Persian Gulf. Remains an almost uninhabited desert. Saudi Arabia possesses what the world desires most: oil. But nature never gives everything. With more than 40 trillion liters of oil beneath its soil, the country still has to spend billions of dollars to produce every single drop of fresh water. Average annual rainfall is below 100 millimeters, while summer temperatures regularly exceed 45 degrees Celsius. To survive under these conditions, Saudi Arabia built a nationwide water pipeline system. The network uses high-strength carbon steel pipes similar to those used in oil and gas pipelines, so they can withstand continuous pumping pressure, mechanical impacts during underground installation, and the extreme thermal cycles of the desert. The rectangular steel plates are cut to pre-calculated dimensions sufficient to be rolled into circular pipes with a diameter of about 1.8 meters and a wall thickness of nearly 25 millimeters. They are then fed through a multi-axis rolling machine where rollers gradually bend the steel step by step until the two edges meet, forming a pipe blank ready for the next stage of longitudinal welding. After the welding is completed, the pipe is passed through a straight-flow water cooling line to reduce the temperature of the weld seam. Next, the steel pipes are carefully ground along all edges and corners to remove burrs and ensure geometric accuracy before further welding. Both ends of each pipe are then finished with beveled edge welds, creating optimal contact surfaces for joint connections. Each pipe segment is typically about 12 meters long enough to reduce the total number of welds while still remaining practical for transportation. This design allows the pipes to be joined quickly, maintain pressure-tight seals, and remain structurally stable over the long term when installed along cross-country pipeline routes. Once completed, the steel pipes are moved to an outdoor storage yard where they are stacked by batches and clearly marked for logistics and tracking. From there, they're lifted onto specialized transport vehicles using forklifts or cranes and securely fastened to prevent deformation during transit. Finally, the pipe sections are hauled hundreds of kilometers to the construction site, where they're welded together directly along the cross-country pipeline route. The installation process begins at large staging yards located along the pipeline route. Here, fully manufactured steel pipe sections are grouped by diameter, length, and installation sequence. Engineering teams carry out final visual inspections, checking pipe straightness, coating condition, and identification markings. Proper organization at the staging area is essential to maintain a continuous workflow, minimize delays, and reduce errors when operating in harsh desert conditions. At the same time, survey teams establish the exact pipeline route across the desert. Using GPS systems, total stations, and terrain data, the alignment is marked directly on the ground with stakes in visible paint. This stage ensures the pipeline follows the most stable and efficient path, avoiding weak soils, shifting sand zones, and areas prone to erosion. For pipelines stretching hundreds of kilometers, accurate routing is critical to long-term structural integrity. Before trenching begins, the construction site must be cleared and leveled to allow heavy machinery to operate smoothly. Temporary access roads are opened parallel to the pipeline to accommodate trucks, excavators, welders, and material transport vehicles. In the desert, site preparation also includes dust control and sand stabilization measures to ensure visibility and worker safety. This is a fundamental step that ensures the smooth operation of the entire construction process throughout the project. Once the route is finalized, large tracked excavators begin digging the trench along the marked alignment. The trench is excavated to precise width and depth, allowing enough space for pipe placement and backfilling. Excavated soil is sorted on site. Suitable material is retained for backfill, while unsuitable material is removed. Maintaining consistent trench depth and alignment is essential to prevent pipe deformation or misalignment after installation. In addition, along certain pipeline sections that cross steep and rugged mountain terrain, explosives are used to carve trenches directly into solid rock, place controlled charges, and detonate them in sequence to fracture the bedrock along the planned alignment. The resulting blasted trench creates enough depth and width to seat the pipeline securely, even in areas where mechanical excavation is impossible. This method allows construction to continue through extreme landscapes while keeping the pipeline buried, protected, and structurally stable. After excavation, the pipe is not placed directly onto the trench floor. A layer of selected material, typically fine sand or screened soil, is spread evenly along the bottom to create a bedding layer. This layer distributes loads uniformly and reduces stress concentrations on the pipe. The bedding is leveled and lightly compacted to achieve the required elevation. In desert terrain with loose, dry soils, this step is crucial for long-term stability. To construct large-diameter pipeline routes, a construction corridor of approximately 40 meters wide is prepared in advance, allowing the entire installation process to proceed continuously at an average pace of about 1.5 kilometers per day. Pipe sections measuring around 18 meters long are selected to reduce the number of field welds, while also imposing very high demands on lifting, transportation, and precise alignment throughout construction. At the welding site, a hydraulic internal lineup clamp is positioned inside the pipe joint and expanded with 360-degree gripping shoes to hold the two pipe sections perfectly concentric and actually aligned before and during the root pass. An automated welding operation supported by a workforce of roughly 80 personnel and dozens of specialized machines is deployed and can complete up to 150 welds per day on 42-inch diameter pipes.